In this lecture, we're going to give an introduction to basic text processing. Here is a short text reporting some company news. J.P. Bolduc, Vice Chairman of W.R. Grace & Company, which holds an 83.4% interest in this energy services company, and so on. Now, to a human reading this text, it's kind of obvious what the words are and where the sentences start and end. But to the computer, a text is just a sequence of characters. Some characters are letters, others are spaces or punctuation marks. And so before we start processing a piece of text with our NLP tools, we normally have to, first of all, break up the text into its tokens. Tokens is the general term for words and other meaningful symbols like punctuation marks and so on. Normally, we also have to group these tokens into longer sequences that we call sentences, because this is typically the basic unit that NLP tools can handle. However, before we can even start segmenting the text into tokens and grouping them into sentences, there may be other things we need to do to make the text processable, so to speak, because text comes in many different varieties. First of all, in order to process the text, it has to be digitalized. So if we have a text that only exists on paper, we first have to turn it into a digital text using optical character recognition or some other technique. Now, even if we have digital text, text is often sort of intermingled with other content elements like pictures and other kinds of graphics. And NLP tools can typically only process the text. So in that case, we need to extract the text from, let's say, the web page where it co-occurs with images and other content. Digital text often also contains markup. Markup either regarding the way it's going to be presented on the screen, as in HTML, or recording some of the logical and semantic properties of the text, let's say using XML. And even though that markup is often useful for processing, we still have to distinguish what is the actual text and what is the markup, and we don't want to treat the markup tags as if they were ordinary words. So most NLP tools require plain text as input, sometimes with markup. And pre-processing is the term that we use for basically extracting and cleaning up the text so that we can start doing the real language processing. We're not going to talk about pre-processing in this course, but it's important to remember that when we're dealing with practical applications of NLP, this is something that we often need to look at. So getting back to tokenization. So given that we now have a plain digital text, which is essentially a sequence of characters, we need to segment this into tokens. And tokens can be grouped into different categories. Now, the most important one, at least from a language point of view, are the words. So if we look at this text again, we will see that chairman is a word that occurs in the text. And similarly, of is another word in the text. Energy services is a compound word written with a hyphen, and so on. So these are among sort of the tokens that we need to recognize in this text. But there are also things that are not ordinary words written with letters. So we have a numerical expression 83.4, and we have punctuation marks like this comma over here. And note that, first of all, we need to separate the punctuation marks from the words, because if we try to look up company comma in a lexicon, we will not find anything. We will have to look up only company. But in addition to that, we want to recognize the punctuation marks as tokens in themselves because they carry important information in the text. In addition to punctuation marks, we also have other symbols like the ampersand or the percentage sign that are essentially words but not written with letters in the usual way. Now, in order to recognize these different tokens, we can rely on a few different information sources. In writing systems such as the one used for English, white space, and in particular the spaces between words, is a very important clue to finding where words begin and end. In addition to that, we have different character classes, so letters, numbers, punctuation marks, that's also very important. And finally, we can often also make use of dictionaries. So if we have a list of words in the language, then that can be a great help for identifying words in running text. After we have performed tokenization, we sometimes need to do normalization. And by normalization, we mean grouping together tokens that contain different characters but should nevertheless be regarded as instances of the same type. So abbreviations is one example. US is an abbreviation that is sometimes written with the dots and sometimes without it. And for certain applications, it's useful to regard these as the same. So we may want to normalize all occurrences in the text so that they look the same. Uppercase versus lowercase is another dimension which we sometimes do not want to distinguish. So if an occurrence of window is capitalized just because it occurs at the beginning of a sentence, we may want to recognize it as an instance of the same word as the lowercase window. So for example, we may want to convert the entire text to lowercase. In lemmatization, we take this one step further and we regard different inflected forms of a word as the same. So window is singular, windows is plural, and for certain applications it's useful to say that they are both instances of the word window. So we may want to map them both to window. And we can take this even further and do stemming. So if we look at words like compute, computing, computer, they all have something in common, both semantically in their meaning, but on the surface also because they've been derived from the same Latin stem. And in stemming, we essentially try to strip off the things that make them different and capture this common element, which we can then use for, let's say, searching and information retrieval. Now, one thing to note here is that the need for normalization is highly dependent on the application. So sometimes it's a good thing to lowercase all words, sometimes it's not. Think about cases like Apple and Windows written with uppercase, where the information that it's capitalized may be important to recognize that this is a company name and a product name, respectively. Similarly, whether it's a good idea to collapse run and runs into instances of the same word also depends on what to use it for, because obviously the inflectional ending does carry information. Now, the final task that we count as part of the basic text processing is sentence segmentation, where we essentially, having recognized the tokens, then group them together into sentences. Now, the sentence is not a very well-defined concept, but by and large in text written as in English, they often start with a capitalized word and end with one of a few sentence final punctuation marks, including the period, the exclamation mark, and the question mark. Now, unfortunately, none of these is completely unambiguous, and in particular the period is highly ambiguous because it is also used for many other things. In 83.4, it's a decimal point, and in US and Corp, it just marks that something is an abbreviation and it's actually part of a token and not a separate token. In addition, in many types of text, final punctuation may be missing. This is true in headlines typically, in different types of lists, and even more so in special text genres like email or text messages and so on. Now, how do we actually perform these tasks computationally? It turns out that all of these tasks are cases of transduction, where we map one sequence to another sequence. It can be the case of mapping a sequence of characters to a sequence of tokens in tokenization, mapping a sequence of tokens to a different sequence of tokens in normalization, or mapping a sequence of tokens to a sequence of sentences in the case of sentence segmentation. Transductions can usually be performed very efficiently using the computational model known as a finite state automaton. And these can be specified using the formal language known as regular expression. So that is something that we will see is very useful for performing these tasks. So what we're going to do in the 2 other lectures in this module is first to look at regular expressions to give us a tool that we can use for basic text processing, and then in the final lecture look more specifically at the problems involved in tokenization.